Group 2 with Anthony Olive, David Gonzalez, and Sebastian Caballero presents the touch sensor desk lamp. Our aim with this project was to construct a light source that would allow engineers to work on their projects with a low-intensity light. To reach our goals, we created a portable desk lamp with the ability to switch between a red and white light, and an on and off mechanism using a touch sensor. This would allow engineers to switch between a low-intensity white light and a non-blue light. Portability would allow them to carry the lamp anywhere. The system is powered by a 9-volt battery connected to an Arduino that limits its voltage output to 5 volts. It also includes 2 small breadboards, 1 capacity touch sensor, 2 tactile buttons, 2 PN2222 PNP transistors, 2 100 ohm resistors, 2 1K resistors, 5 white LEDs, 3 red LEDs, 2 yellow LEDs, and a multitude of jumper cables.
As we saw in the schematic, the Arduino works like the brain of the lamp, because every connection and action is ultimately decided or ends up back at the Arduino. The Arduino receives input signals from the capacitive touch sensor. As the name of the touch sensor suggests, it uses capacitors to detect contact. It does this by using the electric field caused by a human finger making contact with the sensor. This triggers a touch sensor to send a signal to Arduino. As we can see in the code, the Arduino is designed to control an LED using a touch sensor. The LED is connected to digital pin 10, and the touch sensor is connected to digital pin 7. In the setup function, the LED is set as an output and the touch sensor is set as an input. The code then reads the initial state of the touch sensor inside the loop. The program continuously monitors the sensor state and checks for a rising edge, which occurs when the sensor transitions from low to high, indicating a touch has just occurred. When such a transition is detected, the code toggles the state of LED. If the LED was off, it turns on. If it was on, it turns off. This allows the user to toggle the LED on and off with each touch of the sensor.
The project follows a 2-transistor latch circuit. Each transistor is responsible for powering a row of 5 LEDs. The first breadboard is responsible for light setting control. Here we find the latching mechanism. Both latching mechanisms follow the same blueprint. A transistor's collector is connected to power via a 100 ohm resistor. The emitter is connected to the ground with a wire. From here, both transistors are connected using 2 1K ohm resistors. Each transistor connects the collector of one transistor to the base of the other. The bases of the transistors are then connected to buttons. The buttons then connect to ground. The latching mechanism works by becoming fixed at a particular state. Once the button is pressed, a small current will flow to the base of the NPN transistor, allowing current to start flowing from the collector to the emitter. Once this happens, the other transistor is closed and the state switches. This is possible due to the fact that both transistors are connected with each other from collector to base. When the button is pressed, the circuit reaches ground, allowing for a flow of current to the base. Once this happens, the current will stop flowing in one transistor and start flowing to the other one. The second breadboard holds the LEDs. All LEDs are connected in parallel and receive a voltage from the collector of each transistor. The LEDs are then connected to ground, completing the circuit.
As we can see by the results gathered by our MyDeck, our lamp works well within range. This is because the power consumed by the white LEDs is 45.1 milliwatts, which is quite a bit less than the 56 milliwatts which is rated for. The red LEDs in our lamp are consuming power at 29 0.4 milliwatts, which is also well below the 40 milliwatts which it is rated for.